All right, let's finish off our notes, shall we? Let's make this quick here. End behavior. All right, so what's happening at the end of your relationship? Ah. Well, let's show what the math notation looks like. What's the end of our relationship look like? Well, it's going to look like this. As X approaches day, when did the end of our relationship happen? Well, we had that really negative thing we found about them. You know, they don't like cats, or they kicked their dog or something like that. We're like, we're done with them, right? So that happened right there. And so on day 6 was kind of the end of our relationship. So you could say as X approaches let's go day 7, you know, because it seems like our heart rate kind of balances out. So as X approaches day 7, what does the Y approach? The Y approaches 70 beats per minute. Now, usually when we talk about end behavior, we don't talk about a particular X value. But the notation really is as simple as this. As X approaches 7, what does the Y approach? Approaches 70 beats per minute, right? So usually when we talk about end behavior, we mean at the very end of the domain. Now, you might say, I don't know how long I'm going to live. I don't know what day that's going to be. Well, let's just pretend like this is a math equation, and we're thinking, well, see that little arrow right there? That means that it goes out to the right forever, right? So we're going to put down infinity here. That means out to the right. That's what that positive infinity right there means, like going to the right. What does the Y approach? Well, the Y approach is 70, okay? Now, can we go to the left? You know, well, no, because it stops right here at day 0. So the end behavior on this graph would be as X goes to 0, the Y also approaches 70. Now, very rarely do you see this in beginning math, that they talk about end behavior, because they quite often don't have a domain restriction. But, you know, we would probably have just this, you know, we would say that your heart rate was 70 over here as well. So I'm going to make it go out to negative infinity. Like, that doesn't make a whole lot of sense in my story. Oh, geez, I'm trying to put down an infinity sign. That was horrible. Let me see if I can make it any better here. No. Okay, so as we go to negative infinity, what happens to Y? It's also going towards 70. Now let's try one from the homework. End behavior is not hard, but you got to understand what this notation means, okay? So let's go over to this one right here. This is going to be problem number 6. I think this is problem number 6. And you notice how it says as X goes toward negative infinity. Now, here's all you need to know. When it has this little notation right here, it means focus on that arrow right there. Focus on this arrow. What is it doing? Well, it's going down, right? That down, let me put down over here. That down means it's going to go to the left forever. That's what this is implying right here. As X goes to the left forever, it's going to go down forever. So the Y is going to go to negative infinity. So we're going to look for negative infinity there. As X goes to positive infinity, we're looking for the arrow on the right. Let's put that down. We're looking for the arrow on the right. This one means arrow on the left. Where's the left arrow? And, well, what's it doing on the right? It's going up. Okay, so over here we need to respond by saying it's going to go up. Okay, so you're going to look for positive infinity right in there. Let's go back to this previous problem, because that's kind of interesting. The arrow is going down on the left, so that's left end behavior. So as X approaches negative infinity, Y approaches negative infinity. That's really the same as what we had on the next slide here on problem number 6, isn't it? But here we had a line, right? What else could it do? Well, we could have, let's say we had a parabola, all right? Like the basic old parabola like this, all right? Now, what you need to know about parabolas, oh, geez, that's not a very good parabola, is that parabolas go, when they have this little arrow up, it really means it's going to go out forever, and it's going to go up forever and up forever, okay? So here's the end behavior. As X approaches negative infinity, they're always going to kind of say that as it goes all the way to the left, and as X goes all the way to the right, what are the Y values doing? The y value on the left, well, because the arrow is up, is going to be positive infinity. The y value on the right is going up, so it's going to be positive infinity. All right? Now, let's change this a little bit. Let's say it did more like our example with the heart rate, okay? So let's say your heart rate went up for a while, okay, and then it flattened out and approached some horizontal asymptote, like 70 beats per minute, okay? So let's put 70 right here. Now, the only thing I'm going to change is I'm going to change the y's end behavior right here to 70. So it doesn't always have to go to infinity for the y value. It could be flattening out. It could go back down to 0, you know, because you're like, oh man, this person's going to die someday, so their heart rate's going to be 0, right? So let's do that real quick. Let's change it to be 0, just to kind of, you know, make the point maybe a little bit clearer. So what's the end behavior on the right if you said, well, my patient is going to do something like this, and eventually they're going to, you know, be right at 0 the whole way? Well, you change the y's end behavior to a 0. As x goes out to the right, the y is going to get to 0. Okay? Boy, I hope I'm making this clear. That's, as you know, end behavior can be tricky because of notation, but the concept's really easy.